Example 4, in section 9.2, we modeled the current big I of t in the electric circuit shown in figure 5 by the differential equation big L times the derivative of big I with respect to t plus big R big I equals big E of t. See figure 5 where you have a switch, big E, big R, and big L. Back to the text. Find an expression for the current in a circuit where the resistance is 12 ohms. The inductance is 4 big H. A battery gives a constant voltage of 60 big V, and the switch is turned on when t equals 0. What is the limiting value of the current? Solution with big L equals 4, big R equals 12, and big E of t equals 60. The equation becomes 4d big I over dt plus 12 big I equals 60, or the derivative of big I with respect to t is equal to 15 minus 3 big I. And the initial value problem is derivative of big I with respect to t equals 15 minus 3 big I. Big I of 0 equals 0. We recognize this equation as being separable, and we solve it as follows. The integral of the derivative of I, restarting that, the integral of d big I over 15 minus 3 big I equals the integral of dt. Open 15 minus 3 big I does not equal to 0. Close. Negative 1/3 the natural log of the absolute value of 15 minus 3 big I equals t plus big C. The absolute value of 15 minus 3 big I equals e to the power negative 3 open t plus big C close. 15 minus 3 big I equals plus or minus e to the power negative 3 big C times e to the power negative 3 to the power t equals big A times e to the power negative 3t. Big I equals 5 minus 1/3 big A e to the power negative 3t. Since big I of 0 equals 0, we have 5 minus 1/3 big A equals 0. So big A equals 15, and the solution is big I of t equals 5 minus 5e to the power negative 3t. The limiting current in amperes is the limit as t approaches infinity of big I of t equals the limit as t approaches infinity of open 5 minus 5 times e to the power negative 3t restarting that line. The limiting current in amperes is the limit as t approaches infinity of big I of t equals the limit as t approaches infinity of open 5 minus 5e to the power negative 3t close equals 5 minus 5, the limit as t approaches infinity of e to the power negative 3t equals 5 minus 0 equals 5. See the sidebar. Figure 6 shows how the solution in example 4, the current approaches its limiting value. Comparison with figure 9.2.10 shows that we were able to draw a fairly accurate solution curve from the direction field. Y equals 5.